Hello students, good afternoon to all of you.
Good afternoon, ma'am.
We have done up to this one here. A, B, and C. We have proved that these are equivalent. Yes. Any doubt in this? That is, we have taken first A implies B and C, then B implies A and C, and then C implies A and B. Z is connected, has no cycle. Z is connected, it is coming in A and has no cycle. This part of C is done. So we had to prove n minus 1. C has n minus 1 edges, and that will be proving B and C both, right? At the time. So we use induction method, right? And then we took B and B implies A and C, right? So in B, it is given as G is connected and has n minus 1 edges. That is, this one is given, so this one proved has n minus 1 edges, this one done, right? So this one, first half of A done and first half of C done. Yeah.
Ma'am, that day you said, ma'am, that question, no, ma'am. Actually, I'm not getting previous question that day. Half we have discussed.
Which one?
Ma'am, previous one, another question was there, no, that vertex point was explaining that one.
Again, can you again tell me which
No,
type?
actually, exactly, I didn't remember the question, but it was related to something that G1 and G2 was there. Two diagrams were there, and he was explaining about the point C. They were, I mean, he was saying no, if their centers are having same point number of points, ऐसा कुछ बोल रहे थे मैम. Particularly याद नहीं है question, लेकिन उस दिन बोल रहे
So
थे.
in first chapter or in second chapter?
Second chapter.
With many question. Okay. So many.
Ma'am, you continue, ma'am. Later I will find that one and I will ask you, ma'am.
यहाँ तक कंप्लीट किया था मैंने.
Yes, ma'am. Yes, ma'am. मैम वो समेशन वाला जो था ना वही वाला थोड़ा सा है.
ये
यहाँ पे yes, ma'am. G has at least two components rather than two ये वाला.
okay. Yeah, that I am coming to that. First, I explained first one by induction, right?
Okay. Yes, ma'am.
Then next is just it has no cycle. We have to prove. Assume G is B and we have to prove A and C. That is, this is already given and this part is already given, right? Connected and n minus 1 is given. We have to just prove no cycle. So if some cycle is there, then number of edges will not be n minus 1. This will be at least n. So that will contradict our given statement. That's why it has no cycles. So it will be acyclic. Then we took the C as given statement and proved A and B, right? So that is A has n minus 1 edges, this part of B is done and has no cycle, this part of A is done. Now we need to just prove that G is connected, right? You have some problem in this one, I think. C implies A and B. So G has n minus 1 edges and no cycle. We need to just prove because this is one half part of A and B and this is another half part of B, right? So we need to just prove G is connected. Means to say एक ही component होना चाहिए, right? G is connected. If and only if number of components is 1. Now I'm just proving by contradiction or contraposition, whatever you say it. Contradiction. Contradiction में prove करते हैं तो क्या I mean how to start?
To take the opposite.
Take the opposite negation Q. That is, suppose G is not connected. Not connected means components are more than one, right? The disconnected hoga, G is disconnected means G has at least two components. Okay, G1 union G2. अगर एक ही component है तो connected हो जाएगा, right? We have taken G is disconnected means at least two component तो होगा, right? 3 भी हो सकता है, 4 भी हो सकता है, and so on up to K भी हो सकता है, right? This k is greater than equal to 2. Now understood why I have taken this as k? Now, if this is your G actually. G consists of k component and k can be at least 2. Okay. Now, these k components are connected graphs, right? These are the components, means maximal connected part of G. So, these itself a graph, right? G1 itself is a graph with with order n1 and size is m1. G2 is itself a graph with order n2 and size is m2 and so on up to gk. gk का order है nk and size है mk, right? Now g का order में निकालना चाहूँ. So what will be collectively? I have to collect all these, right? Count all these. Clear? ये सब तो g बना रहे हैं. This is your G. So for G, order of G, it is N, that will be N1 plus N2 and so on up to Nk. Right? This is I is running from 1 to K and I. Okay? Summation of all Ni. And size, I have to count all the edges in G1, G2 and so on up to K. So size of G will be summation of Mi. Okay? Clear?
Yes, ma'am.
Now, each component of G is a tree. Why is it? Yes, this is each component is connected, right? Connected maximal subgraph. So connected हो गया वहां से, right? And it is given that G has no cycle means इसके component में भी cycle नहीं होंगी, right? Clear? Connected plus no cycle. This gives you tree. So हर एक GI, every component of G become a tree. एंड ट्री के केस में वी हैव प्रूव दैट अगर ni ऑर्डर है तो इसका साइज कितना होगा? साइज कितना होगा ट्री के केस में?
Ni minus 1.
ni minus 1, right? So each component of this G is tree. That's why size of each component become ni minus 1. That's why it is becoming like this. Okay. Now just put this value or here. What do you got? M is equal to summation of ni minus summation of 1 up to I is running from 1 to k, right? So what do you got? Summation of ni minus 1 plus 1 plus 1 and so on k times. So k times it will be added. So minus of k. Clear? So what is this? This value?
N.
This counts all the numbers, na?
N.
Number of
N.
what is it? N minus k. So what do you got? M is equal to n minus k. Clear? M is equal to n minus k. Now k की value कितनी है? At least 2 ना? If I put k is equal to 2, what I get? n की value क्या क्या हो सकती है? If k is equal to 2, n minus 2. If k is equal to 3, n minus 3. If k is equal to 4, n minus 4. And so on. Clear? So, can you tell me, is the possibility of m ever be n minus 1? Yes. Number of edges n minus 1 हो सकती है क्या इसके according?
No, ma'am. No, ma'am.
No. But given is what? It has n minus 1 size, na? So, which is not possible, right? This is not possible. So यहाँ से हमने क्या कंक्लूड किया था? m is at most n minus 2, right? फिर तो डिक्रीज होता जा रहा है, right? n minus 3, n minus 4. So at most it can be n minus 2. So it can never be n minus 1, which is not equal to n minus 1. Clear? That's why whatever we have assumed is wrong. That is, we have assumed there are at least two components, so that component thing is uh, absolutely wrong. There is just one component, and whenever one component means it is connected. Okay. Yeah, what do you wanted to ask? Yes. Any doubt?
No, ma'am.
So we have both GS connected. Clear? We are done with A. C implies A and B. Because A का half part G is connected to show करना था, right? And B का भी same था, connected show करना था. So this we have done. So we have proved A if and only if B, if and only if C. These three things we have proved. Now we needed to prove four things now. So any one of these you can take, and if and only if D you can prove it. Because all these are equivalent, we have already shown, right? Now you can take any one of these and implies D. D implies that statement, whatever you are taking. Okay. Now, if I give you that a forest, there is a forest F that contains K component. Okay. Forest consisting of K component. And component of forest are trees. Clear? Each component of a forest is tree. Forest is what? Acyclic graph. And component, each component is connected. Connected plus acyclic become tree. So forest is this collection of, it is given that collection of k number of trees. Okay. And forest का order है n. Then what can you say about m? Yeah. A forest of order n having k component. Okay. K number of components are there. What is the size of forest?
N minus K.
N minus k. That you can easily calculate by using this one, right? Got it? So k components means यहाँ वाले k component ले लेना, right? G1, G2, F1, F2, Fk, right? And each component is tree. That's why you can just say mi, the size of each components is ni minus 1, and then you just put it and you're getting n minus k. Clear? Finally, the size of forest will be with n minus k. Okay? And here I have written a forest of order n having k number of tree, or it could be like k number of component having k component has size n minus k. Got it? Now we have proved three statement. Now it's time for fourth. Fourth is A. Any one of them I have taken. That is A. A implies A. A statement is G is connected and has no cycle. Okay. And what was the D statement? What was D statement for any U to V, U and V, any two vertices U and V, there exists unique path between them. Okay. That is, every two vertices of a tree are connected via unique path, connected by unique path. There is exactly one path. Okay. What if अगर unique नहीं है तो? What if there is at least two paths? This means exactly one. We need to show that G has exactly one U to V path for every U to V vertices. U and V vertices. Okay. Suppose not, that is again contradiction. Then what will happen? There will exist at least two paths. तो यहाँ पे U vertex है, यहाँ पे V vertex है, and you have one path is this one, and another path is coming from here. What is happening now?
Cycle is forming.
Cycle, na? You can form cycle by using these two paths. Okay, which is not possible. Here, given is this is acyclic. Okay, and this path could be like that also. ये दूसरे वाला पाथ यहाँ तक सेम है, फिर ये ऐसे जा रहा है, राइट? Q to V. पहले वाला पाथ ये था, सेकंड वाला ये है, थर्ड भी हो सकता है, राइट? So it has, you can form a cycle out of by using these two paths, right? And which is not at all possible in a tree, or you can just say in a connected and acyclic graph. Clear?
Yes, ma'am.
Yeah. Next thing is you are given each two vertices, every two vertices U and V are connected by exactly one path, unique path. Then G is connected and has no cycle. You need to prove A. Given is there exists exactly one path between U and V vertices. Okay? Between U and V vertices, and you need to show that G is connected and has no cycle. This time this is given, and to prove this one. How to prove? Yes?
Prove by contradiction.
By contradiction, you can also prove this. G is connected, obviously. Why is it? See, every two vertices are connected by exactly one path. Exactly one path हो, two हो, three हो, हमें इससे कोई मतलब नहीं है, right? G is connected. Whenever every two vertices are connected, right? Clear?
Yes, ma'am.
So connected part is done because every two vertices are connected by some path. Now need to prove just has no cycle. If some cycle is present, by contradiction I'm just trying to prove this part, then what will happen? यहाँ पे U है, यहाँ पे V है, and G has some cycle. Then what will happen? Is the possibility of unique path is gone, right?
Not
जब
there.
भी cycle आती है, then at least two path तो होंगे ही होंगे, right? That's why which is not possible. Whatever we have assumed is wrong. So it will become acyclic. And why this is wrong? Because exactly one path is given. Clear? And you can just see this one. Yeah. D is given, G has unique path, G is connected as every two vertices are connected, have a path. Unique है या two है, don't care about that. Now, G has no cycle or acyclic we need to prove. If G has some cycle, what will happen? There will be some points with at least two paths. Okay, and that is not at all possible. exactly one cycle. Adding one edge to a tree forms exactly one cycle.
Yes, ma'am.
True?
True.
How to means explain this one? Every two vertices, whether it is this one or this one or this one, they have unique path. Clear? Every two vertices, u and v, you can just say. So by adding one edge will create just one cycle. Clear? You are adding one edge, exactly one edge, this cycle. Or you can also add u to ws, creating this one cycle. Because exactly one path is there, okay? A tree has a unique path between each pair of vertices. That's why it is happening. Okay? Any doubt? If you have any doubt till now, you can tell me. Yes? So what we have done till now in chapter 2, 2.1, define tree, forest, right? And then we did some examples of tree. Then we did one lemma, that was every tree, single tree you can just say, has at least two leaves, right? At least two number of leaves. And if you delete one of them, you will get another tree of order n minus 1. Okay? Then, then we did this four statements we have shown. Four statements are equivalent. That is all the properties of tree, that is G is connected, having no cycle, n minus 1 number of edges, and there is exactly one path between each pair of vertices. Okay? And then we have done every edge of a tree is bridge because no cycle is present, that's why it is happening. And adding one edge to a tree forms exactly one cycle, that means because of unique path between each pair of vertices. Clear? So that's all we have done. Any doubt till now? Yes? No doubt?
No, ma'am.
Now, spanning subgraph, spanning tree. Tell me about spanning subgraph. We have done it, right? We have done induced subgraph and spanning subgraph. Yes. Spanning subgraph. Anyone remember? Hmm? Anyone remember it? Spanning subgraph.
Ma'am, number of vertex are same.
It should be subgraph first, right? Spanning subgraph. If subgraph with same number of vertices. Okay. So spanning tree means to say spanning subgraph which is a tree. Okay. Tree means connected acyclic. So all the vertices should be there. Okay. Clear? And no cycle should be present, and this is connected, means the least possible connected graph. Clear? Got it? The spanning subgraph is the tree. For example, in this case, we have spanning subgraph. This one, okay. Also this one. Any other? Can have this one. This to this, this to this, this to this, this to this. That is P5. That is isomorphic to this one. These are the spanning tree of this graph. Okay. We can find spanning tree for any graph. Can we?
Yes.
Okay, I'm giving you one
No. For only cycle one.
for only.
Some graph contains cycle.
Okay, I'm giving you some graph contain cycle only. This one union with this one. Can you find spanning tree? You have G containing these two graphs. Does there exist any spanning tree? Can you find spanning tree for G? Spanning subgraph से exist बहुत सारे कर रहे हैं, right? But acyclic नहीं हो सकते हैं. But what is the condition? Connectedness will never be there. Okay? Are you getting it?
Yes, ma'am. Getting.
So disconnected is gone. So every connected graph, whether it is already a tree or not, what is the spanning tree for P5 or Pn? Itself only. Okay. So every connected graph contains a spanning tree. Okay. Here, every connected graph contains a spanning tree. So two conditions may be there. Spanning tree, connected graph, it is already there, right? And it contains n vertices, and spanning tree means it will also contain n vertices. So connected plus acyclic it will be, right? So if G is already acyclic, then itself it will be a spanning tree. If it is not acyclic, that is some cycle is present, so you will make it acyclic, okay, by removing some edges, and then least possible connected graph will be your spanning tree. Clear? So if G is acyclic, then itself is a spanning tree, and if G is connected, that is G contains, this connected already given, G contains some cycles, G is not acyclic, then what you will do, you will delete some edges one by one, okay, from that cycle, whatever possible cycle is there, so that it will be the remaining graph will be connected plus acyclic. Okay, and yeah, you will not remove any vertex. So you are remaining, all the vertices are same. The graph is, the subgraph part is connected plus acyclic. So this is the criteria for spanning tree. Clear? This is tree, this is spanning. Okay. This connected graph does not contain any spanning tree. Yeah. I'm just giving you one example. This is the graph G. Can you find two spanning tree? Can you give me two spanning tree for this one? This one, spanning tree. Clear?
Yes, ma'am.
This one is also spanning tree. And there are many more examples like so then what you do t minus e. T minus e will be looking like this one, right? This is your t minus e. Okay. Got it?
Yes,
This is
ma'am.
your t minus e. And you just add e dash. E dash. E dash if you will add this one, you are getting a spanning tree or not? Plus e dash. Getting it? Okay. Or it could be like this also. For example, this is not this one. You are having this one. Then what will happen? This one, right? T minus E plus E dash. We have taken this as that was not present in T dash, and we have taken one more as that was not present in T. So we have removed this as from T which was present. So we got this graph, and then we have added E dash that was present in T dash. So one edge we have removed from this one, that was the edge from here itself, and added one edge from T dash. So we are getting this one. Is this spanning tree of this graph? Yeah, it will be spanning tree, right? So spanning tree, you know that n vertex tree will be having how many edges? N minus 1, na? Clear? And without cycle, right? So n vertex n minus 1 edges. Here also n vertex n minus 1 edges, n vertices n minus 1 edges. So the newly added, that is first we have subtracted it, means we have made it n minus 2, and then we have made it again n minus 1 by adding some other edge, right? So we are just maintaining this one size and order. Okay, size is n minus 1, order is n, and no cycle is present. Okay, why no cycle is present? We are removing the edge, na? Then we are disconnecting this graph T. यहाँ से ये edge गया तो disconnected हो रहा है, and there is some other edge E dash is present that connects these two components of T minus C. You get this one. Okay, T minus E plus E dash. So this will be new spanning tree that may be same as T or T dash, doesn't matter, but that will be also working as spanning tree. Okay. If you are adding same number of edges and same number of edges you are removing, so no cycle formation will occur. Okay, always it will be spanning tree. Clear? Here, if T and T dash are spanning tree of a connected graph G, and the edge E we have taken from T but not present in T dash, then there will exist, there is an edge E dash that is present in T dash but not in T, such that T minus E plus E dash is a spanning tree of G. Okay, so the remaining thing, whatever we have taken from T, the edge, so we have subtracted it from the T only and we have added the T dash edge, E dash. So this is the spanning tree. Clear? Got it? How to explain it? Now T minus E will be disconnected. Why is it so? If we are removing it, we need T minus E plus E dash, right? Okay, we need T minus E plus E dash. So T minus E is disconnected. Why? Because every edge of the tree is bridge. Clear? That's why T minus E will be disconnected after removing that edge. So these are the two components U and U dash of T minus E. Means T minus E can be written as U union with U dash. Two components of T minus E. So these are the disjoint. Now T dash is also connected. So that is the spanning tree, right? And this is also having some edge. We have taken one edge, that is having endpoint, one endpoint in U and one endpoint in U dash. So after adding this one E dash, what we are doing? We are again connecting U with U dash, right? We have U and U dash over here. So we have taken some another this T dash, this spanning tree, and we have taken that as of T dash that connects U and U dash. And this type of edge will surely be there because of T dash is connected. Okay. So this E dash is again connecting your U and U dash, right? T minus E plus E dash will be connected, and obviously again it forms n minus 1 number of edges. Okay, पहले एक separate लिया था, तो n minus 2 again we have added, so means n minus 1 edges are there, right? And this is also acyclic. Clear? This is acyclic. That means it will be, and why this is acyclic, connected in acyclic? We have done now a graph G which is connected and has n minus 1 edges, that it will have no cycles. Clear? We have done it. That means acyclic. So this graph, this subgraph is connected plus acyclic means spanning tree. Okay? Clear? I have already defined kind of scenario. Right? I explained it. If you remove this edge, you need to add one more edge that is having some endpoint between, some endpoint is that is present in U on endpoint present in U dash. So the new spanning tree will be this one. Okay? Any doubt? Hmm? Is any doubt?
Ma'am, Once again, please. That question.
This question.
This question.
Okay. ये समझ आया था
Yes, ma'am.
कि यहाँ पे this one we had T. We are having two spanning tree. Okay, T and T dash. Clear?
Yes, ma'am.
So what we are doing, uh, this one is the spanning tree and this one is the spanning tree. We are taking one edge from T that is not present in T dash. Okay, अगर हम ऐसी edge लें जो T में present है but T dash में नहीं है, and then there will be some edge which is present in T dash but not present in T, such that if we remove this ES from T dash, that is this one removed and this one added to this, okay, plus E dash, then will we get connected an acyclic graph? That means will we get again spanning tree?
Yes, ma'am. Yes, ma'am. Got it.
That's what it is asked. It is just
Okay.
explaining, okay. The number of edges अगर same है, means you are just taking that as only which is not present in the other one, and then there will exist some other edge which is not present in this one, and if you are removing this one and adding the other one, then again you are ending up getting this spanning tree. Okay. Yeah. Now it's distance in trees, distance between any 2 points. So if I ask you, how many paths do you know from A to G? Distance in the graph actually. In tree also you can find. You have exactly one path. So in tree there will be exactly one distance. Okay. Yeah. How many paths exist from A to G? You have A, C, D, G. One is this one. Another is A, B, C, D, G. Another is A, B, C, D, H, G. A, C, D, H, G. Or A, C, D, E, F, G. Right? Or A, B, C, D, E, F, G. Clear? There are many paths. A to G path. Clear? In this graph, this maybe tree or may not be tree. Okay? In fact, in this one, this is cyclic, means cycle is present, no tree. Okay? So you have A and G many paths. Out of them, which one is the smallest path?
A, C, D, G.
A, C, D, G. This one. The length of this smallest path is determining its distance. Okay? And it's denoted by D of U comma V or D of U comma V. That is from in graph G. This is distance from U to V. Okay? Or you can just say distance between U and V. As we don't have this one in directed. Okay? If direction is that, you need to just check for directed graph. Clear?
Yes, ma'am.
Yeah. So what is the length of this A to G path? Not length of A to G path. Distance. Distance from A to G. Distance between A to G. There are many paths, but you will look for the smallest one. Distance from U to V or between U to V is the length of smallest path, smallest U to V path in G. So here it is 3. Clear? Similarly,
Yes, ma'am.
from A to B, from A to B,
1.
yes, 1. A to C, again 1. Clear? You have many paths, but smallest one is 1. A to D, 2. A to F, A to F,
4. 4.
4.
4.
There may be more than one smallest path, right? So that is A to C, then D to C to D, B to E, then this one. Or directly you can go from here to here and then this one, right? Both are the smallest path, right? Both are giving you same distance. Okay? So A to F is F to A or A to F. The distance between A and F is again 4. What about B and F? B and F, B and Z?
Ma'am, B and F is 4.
Again 4.
B and G is again 3, 3.
Path is this to this, or this to this, and to G you have 3, and then via G also you can reach up to this F point or via E also, right? But the distance is the number, na? So that is for both via E or via G. Clear?
Yes, ma'am.
Now it is the possible that G is disconnected, right? If there is no U to V path, U is some other component, V is in some another component. Then you cannot find any path, right? U to V path. Then what you consider U and V, distance between U and V is infinite because we are not able to find a path. Okay? Here,
Yes,
any
ma'am.
doubt in distance?
No, ma'am.
No. Now, distance is the smallest length UV, that is smallest path length. Okay, smallest path length between U to V. Right. Now diameter. Diameter is what? You take the greatest distance among any 2 points. Distance is from U to V, but you take all the distance you calculate it, and out of that, the largest one, greatest one, that will represent your diameter of the graph. Okay, so diameter of the graph is the maximum distance, greatest distance among any 2 point, you can just say, or you can just say among all the distances DUV. Okay, first you find all the distances and then take the maximum. Okay, in short, you can just write this one, maximum of UV is coming from VG set DUV. Okay, so what can you say about diameter of G1 over here?
4.
Oh, there does not exist any that is any path, any distance with path length 3. Okay, any path with any smallest path with length 5, not 3. Okay, so only maximum is 4. You have many, right? A to F, B to F. So that is your 4. Okay, and if you take minimum of them, minimum, that will give you diameter. I think diameter तो है radius. Diameter is the maximum. Radius I'll explain. First, I need to explain this eccentricity. Okay. See, diameter तो है graph का. Okay. Distance थी between 2 points. Okay. Don't get confused between that. Diameter we are calculating for the complete graph. Okay. Now eccentricity. Eccentricity for the one vertex. Okay.
मैम
Clear? Yeah.
मैम जो डायमीटर है वो सिंपल ग्राफ के लिए डिफाइन होता है कि मल्टीपल ग्राफ मल्टी एज ग्राफ के लिए भी हो सकता है
मल्टी एज होगा तो भी वो वाला, फॉर एग्जांपल इफ देयर इज काइंड ऑफ दिस वन, then also it will be same, no? It's loopless graph. Okay, मल्टी ग्राफ में भी फाइंड कर सकते हो. Okay,
ओके
मैम इसका
yeah.
एग्जाम्पल में 5 होना चाहिए ना. diameter of G1 equals to 5.
Why is it so?
Ma'am, A to E, then
A
it's
to
5.
E. A to E. So A to E. A, C, D, E. You have three.
Ma'am, if we A, C, D, G, F, E, then
That is not giving you the distance between A to E.
okay,
I think you are confused between length of a path and distance.
okay,
Length of U to V path may be different from distance between U and V. Distance is the smallest path length. Okay. Smallest path is this one, direct. Okay.
okay, ma'am, okay, ma'am.
There may exist many paths, but the smallest one is giving you distance. Okay. And this largest distance among all the distances, if you run over the vertex set, then it will give you diameter. Now eccentricity. Eccentricity is maximum, this is again largest, maximum distance from the point U. What is the difference between diameter and eccentricity? This is again maximum, na?
Yes, ma'am, but diameter is the property of the graph, whereas eccentricity is the
Yes.
property of two
Eccentricity
vertices.
is the property of vertex. So ये वाला एक ही vertex से largest distance वाला count होगा, right? Eccentricity, but here we will run over both the vertices, U and V. Okay. So eccentricity is the maximum distance from the vertex. Okay. Now you find the eccentricity of A. These vertices. Yeah. All vertices of G1. Eccentricity of A. Maximum distance
4,
from A.
4.
4, right? And that distance is via G to F or via E to F. Okay? So both. So if A की 4 है तो F की भी 4 होगी. Right?
Yes, ma'am.
What about B? Again 4. Right? Just do
Yes,
this
ma'am.
1, 1, 2, 3, 3, 4. Right? B to F. F to B 4. What about C? Eccentricity of C.
Four.
Again 4. 4 or 3?
Ma'am, 3.
3. 3, ma'am.
3. You're having here 1, 1, 2, 2, 3, again 2, E, F. F is giving you the maximum possible distance, right? So this is your 3. What about D? D,
And 2.
2, right? Means every vertex is just maximum at the 2 step away. Okay? In the range of 2, you can just say, right? Every other vertex you can find in the range of 2. Yeah. H, 3,
Three.
3, 4, 2. What?
3, ma'am.
3, ma'am. 3.
What about G?
3.
Four.
4?
Four. Four.
Where? Which distance you have? G से कौन सा वाला 4 4 के
3,
बीच में है?
ma'am.
3.
CH, DC, A.
3. You have all the vertices up to range 3, na? ये तो 1, 1, 2, 2, and A and B. 3. Okay? ये भी 3, ये भी 3. Okay? Now I'm giving you one more formula for diameter. Diameter is your maximum of U and V distance, right? So if I just write this as maximum of U, maximum of V, then EUV, right? Maximum of V, maximum of U belongs to VG belongs to VG, DUV. Okay? What is this? Eccentricity. Clear? Eccentricity. And eccentricity for V. Eccentricity for V. And this is giving you maximum of V. Okay? So, find all the eccentricity and get the maximum eccentricity of all the vertices V or U, you can just say. That will give you the diameter. So, यहाँ maximum eccentricity कितनी आ रही है? 4 ना? And 4 is the diameter, maximum distance. Okay? And the minimum eccentricity will give you radius. तो यहाँ पे radius कितनी होगी?
2.
2. Okay, diameter 4, radius 2. Just don't do here 4 by 2 is 2. Okay, so that is happening only in case of circle. Yeah, radius is defined as minimum eccentricity. Okay. And diameter I already used. Okay. That is eccentricity of U and take the maximum and radius is minimum. Yeah. Find the eccentricity of Petersen graph. And what is this Petersen graph? This structure is known as Petersen graph. Yeah. First tell me what is order, size, degree, regular or not? If regular, how much is the regularity? What do you stand by regular graph? Yeah, regular. On the basis of what you defined as regular? Regularity किसके बेस पे होती है?
Symmetric basis.
And what do you understand by symmetry? Symmetric graph तो if direct diagram symmetric diagram पढ़ा था ना? Regular graph, regularity, degree sequence, degree. If all the vertices have same degree, then we say this is regular, right? Revise नहीं कर रहे हो? Yeah. Tell me order. Order is 10.
10.
Size 5 outside, 5 in this star, and this 5 these. 15. Okay. Regularity. Every vertex has degree. Same or not?
Yes, ma'am.
Same. So this is 3 regular graph, right? R means regularity. And yeah, eccentricity. Yeah, this is connected. And is this bipartite graph? Bipartite graph. Graph is bipartite if and only it does not contain any odd cycle. Now tell me, bipartite or not? It contains C5 na odd cycle, so not bipartite. Yeah. Now tell me eccentricity of every vertex. For eccentricity of any vertex, you count the maximum possible distance, right? This to this, these are adjacent. Adjacent have just 1 degree, right? What about this? This vertex, via this one you can go. This vertex, via this you can go, right? Smallest possible distance, smallest possible path length. And then this to this, again, you have two. This to this, you have two. This to this, again two. This to this, again two. And here also two. And all are kind of this. This graph is kind of symmetric graph. Symmetric in the sense every other vertex behaves like this vertex only. Okay. The maximum possible distance will be two. Na clear? Are you getting it? So eccentricity for every vertex in the Peterson graph is 2. Diameter is maximum distance, maximum eccentricity, and minimum eccentricity is given by radius. Okay, so everything over here is 2. So you need break or can we continue?
Break, ma'am, break.
Okay, 5 minutes break. Hello students, am I audible? Today is Wednesday, right? आज तो क्विज था ना, किसी ने बताया नहीं? Are you ready for the quiz? Yes, everyone, am I audible? अब किसी को नहीं सुनाई दे रहा है ना? Good. Hello. Are you ready for the quiz? Yes? No one responding. Why? Yes or no? How many are ready? Tell me. Ready. Quiz. How many are present? One left. Good. Akars. Akars Vatraj. Okay, not present. Just joined. Adarsh Patel. Adarsh Patel. Aditya Narayan.
Hello, ma'am.
Aditya Narayan.
Am I audible?
Yeah. Who is this?
Present,
Others.
ma'am. Others.
इतनी देर से कहा था क्विज के लिए पूछ रही हूँ ना?
Sorry, ma'am.
Tell me, are you ready or not? No, I don't want your sorry. Either it is yes or no.
No, ma'am. There are so many topics and definitions. I am having the way to remember them all.
Aditya Narayan. Aditya Nayak. Akanksha Srivastav. Alek Kumar Parida. Amitya Vikram. Anjali Priya. Anjali. Ashish Sahu.
Yes, ma'am.
Yes, what about quiz?
Not prepared fully. Not prepared fully.
Not prepared fully. Are you prepared partly? Quarterly? कुछ तो प्रिपेयर किया होगा? Good. Ashutosh Ranjan?
Yes, ma'am.
Ashutosh Ranjan?
Yes, ma'am.
Yes. What about quiz? Yes. Prepared fully?
Partially.
Actually, okay. Aisa? Aisa? Ayush Khan? Ayush Khan, Ayushman Nayak, Ayushman Rath, Bhumika Jena, Bhumika, Vishal Biswas, Deep, Gurman Singh, Harsh Pandey,
Yes, ma'am.
oh, I thought you are not present. Okay. Quiz,
Ma'am, not fully prepared yet.
तो कब होगा? यस दीप, कब तक हो जाएगा? दीप चल लिया नेक्स्ट वीक. ओके. इसी ढाल
Yes, ma'am.
क्विज.
No, ma'am. I was doing a IGT assignment, ma'am. Yesterday the link has come, so I was doing.
Submitted.
Yes, ma'am. Submitted today morning only. I have submitted.
खुद से किए है ना सबने? There was
Yes,
only
ma'am. Yes,
5
ma'am.
question.
Yes, ma'am.
Ma'am, actually,
Yes,
ma'am, you
ma'am.
give us, ma'am, time, ma'am. Next week we'll get prepared, ma'am. Actually, we didn't receive the link, and we
Actually,
are
I gave
getting
you
the
time.
assignment of all
I gave
subjects.
you time. It was on Saturday.
Ma'am,
then
other subjects was also given, no, ma'am. Ma'am, CTC and DSA, we have to do all these assignments. So this week we didn't get time to prepare, ma'am. Actually, we are writing all the assignments.
Okay. Okay, be ready for next week
Yes, ma'am.
Okay, ma'am.
or Saturday this week.
Ma'am, next week
No,
it will
ma'am,
be
next
good,
week.
ma'am. Saturday, ma'am, we have to prepare for CTC lab, ma'am. That's why, ma'am. Next week is good, ma'am.
कमल ने कामरूप महापात्रा, प्रीति
Ma'am.
present. Okay. Manish Saw, Mihika Satvati.
Yes, ma'am. Yes, ma'am.
Okay. Nikita Mahto,
Yes, ma'am.
Nilesh Ranjan Nayak, Isikant, Pradipta Kumar Pradhan, Pradyumna,
Yes, ma'am.
Pranav Nayak,
Yes, ma'am.
and this Pravivik Ray, or it is Pravivik. What is this?
Yes, ma'am. Pravivik.
Pravivik. Okay. Robin Patra, Sagar Das, Swarup Das, Nathan Patra, Sanskar Kumar Singh,
Yes, ma'am.
Saswat Samar, Satya Ranjan Das,
Yes, ma'am.
Shivam
Yes, ma'am.
Srivastav,
Just participative period, ma'am, not complete.
Subhranshu, Swam Swai, Tibun Mohanty,
Yes, ma'am.
Avisar, is this Avisar Singh, Avisar Singh, Gaurav Deshmukh, Srinath,
Yes, ma'am. Yes, yes.
uh, this
No,
is
not prepared. Srinath.
why?
I'm doing
When
IGT assignment.
okay. Subhabrata Saha,
Yes, ma'am.
yes, what about quiz? अभी तो सब आ गए, स्टार्टिंग में कोई नहीं था, है ना? क्या सो रहे थे क्या सबके सब?
No, ma'am, not prepared.
I'm asking some other question now. Subham Acharya,
Yes, ma'am.
Subhas Mandal, Sudhanshu Prasad,
Not prepared, ma'am. Next week.
Sushant Dhar, Swaroop Anjan Behra,
Yes, madam.
Swaraj,
Yes, ma'am.
Prem Jyoti,
Yes, ma'am.
and yes,
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 ma'am.
Sahai.
I'm prepared. I'm partially prepared.
लोग यही बोल रहे हैं. Okay, it's been 10 minutes. Yeah. Now it is hypercube. So eccentricity in hypercube. Hypercube is cube in k dimension. For example, cube in 3 dimension you already know, right? Kind of this one. It's not exactly cube looking like. Anyways, yeah. This is cube in 3 dimension, right? So this is Q3. Qk is hypercube, that is cube in k dimension. Cube in 3 dimension. Cube in 2 dimension. How it will look like? Square. Okay. This is Q2. Cube in 1 dimension. Q1. That will be this one. Okay. Now, this is K2. Okay. Q1 is, we consider K2 as Q1, and then we can find Q1 is equal to K2. Okay. And then we can find, this is Q1, not Q2. We can find Qk by using the last Q, Qk minus 1 multiplied with K2. Okay? Here, that is this one. This one is K2 multiplied with the cube in K minus 1 dimension, or the other way around. Anything you can write. And this multiplication is also written as this one. So how you find Q2 by using Q1? Q1, that is K2 only, right? So how you find this square part? By using K2. Okay? Q2 will be what? K2 into Q1, right? Clear? K2 into Q1 or Q1 into K2, anything. And how we multiply it? So let me explain how we are multiplying. After multiplying, what we will be getting, this is K2, again Q1 is again K2. Okay. So first I'm just giving you, suppose there is G graph, there is H graph, how the multiplication of G and H or H and G will look like. So H is your, G is suppose your K2 and H is your P3, your P2 or P3, okay? P2, P3. Then how will be the multiplication this way, or you can just write this one, box type, anything, how it will look like, okay? So this will be, you take one copy of G and put in place of vertices of H, or you take the copy of H and put in place of vertices of G, okay? So suppose U and V are the vertices and I'm just taking copies of X. This is your H copy placed at in place of U vertex, okay? And in place of V vertex we have taken another copy that is in place of V, okay? So H I have put it over here and again one put over here, okay? Now these suffix, this U and V, these are adjacent if and only if they are adjacent in the G, okay? So the corresponding vertices in these copy will be adjacent if U and V are adjacent in G. So are these adjacent? Are U and V adjacent in G?
Yes, ma'am.
So these corresponding vertices will be adjacent. Okay, these edges are coming from adjacency of U and V. These one. Clear? Or you can also find H cross G or G cross H. So first, if you want to put the copy of G in place of this one, so what you will do? This is one copy ABC. Okay, this is A copy of G. This is B copy of G. This is at C place, C copy of G. Now you just check whether A and B are adjacent in H or not, right? This is GA. This is GB. This is your G at place of C. Okay. Now A and B are adjacent or not in H? They are adjacent, right? Look at these vertices. Are these adjacent? A and B adjacent, B and C adjacent. So these will be adjacent. Okay, the corresponding vertices. Okay, so this is your G cross H or H cross G. Both are same, na? This one or this one. Any doubt in finding the product? Now you can easily find this K2 cross K2. K2. K2 will be this one. And one more K2, you can write over this one. One copy, put it over here, put it over here. These will be adjacent, right? So this is one copy we have put, and these are adjacent. That's why these are adjacent. So this is Q2, right? Then what we are doing? Another thing is what? Q2 cross K2, Q3, cube. How we got it? One copy put in place of this vertex. One copy of Q2 put in place of in this one. Or what do you do? K2 copy put over here in these four places and make them adjacent, the corresponding vertices. So I'm just putting this Q2 copy over here. So one copy upward, then one copy over here. Okay, and the corresponding vertices will be adjacent if these are adjacent. These are adjacent, that's why these will be adjacent. So this is you got Q3. Like this, you can also find cube in 4 dimensions. Okay. Cube in 4 dimensions will look like one cube in this one and the corresponding adjacent vertices will be adjacent. Okay. Are you getting it?
Yes, ma'am.
Yes. Now tell me, what about the eccentricity of Q1? That is K2 itself. This is your Q1, Q2, Q3. Eccentricity over here with every vertex of Q1. Tell me.
1.
1.
You have maximum possible distance is 1. What about this one? Q2?
2.
Q2? Distance from this to this 1, this to this 2. So maximum possible 2.
2.
And all are having same property with this one. So 2, all the vertices are kind of same, no? 2. And in this case,
3.
Q3, it will be 3. And the 3, this to this vertex 1, adjacent vertex 1, and this to this or this to this, you have this to this vertex or this to this vertex. All these are 2, but this vertex, the diagonally, this is having 3 distance, right? So this is 3, so 1 is 3, other are same, 3, 3, 3, 3, right? Now tell me the distance, and distance is already done, diameter and radius. In case of QK, it will be KK, right? Q3 it is 3, 3, Q2 it is 2, 2, Q1 it is 1, 1. So in case of QK, it will be eccentricity of every vertex will be K. Understood? Clear?
Yes, ma'am.
So diameter and radius will be same. Maximum will give you diameter and minimum will give you radius. So radius and diameter, that is K. Yeah. What about CN?
Ma'am, in Q3,
Yes.
the radius will be 1, na?
Radius 1. Why?
The smallest distance.
The minimum eccentricity.
Yes, ma'am.
Minimum eccentricity is your radius.
So, ma'am, the corner, the edge side of the Q is only 1, na?
Yeah. This one with this one, it is 1. But what about
Yes,
the
ma'am.
range? Minimum range, you can just say. Or what should I say? Eccentricity you got for all the vertices, and the minimum eccentricity among all these, that will give you radius, and maximum eccentricity will give you diameter. That is the definition.
Yes, ma'am.
So that's why it is coming as 3, 3, 3. Yeah, what about C3? C4?
Ma'am, 2.
C3?
Also 2.
2. Sure?
Yes, ma'am.
Okay. What is the maximum possible distance from this point?
No. In C3, 1. Sorry, ma'am.
C3 1. From this one
Yes.
also 1. Diameter and radius?
1,
Diameter 1. Radius 1.
1.
Everybody? What about C4? C4 we have already done in this one.
Yes, ma'am. Yes, ma'am.
2.
Yes, ma'am. Get it.
2, 2. Yeah, what about this one? Radius and diameter 2 over here. What about this one? This to this 1. This to this 2. This to this. What about this to this distance? 3 or 2?
2, ma'am.
2, right? Via this one. We will not take this path. We will take this one. Okay? So path length is 2. The smallest path length, that is giving you distance, and then maximize it. That is giving you eccentricity for each vertex. And maximize among all the vertices, that is giving you diameter, and minimize it, that will give you radius. Okay?
Yes, ma'am. Yes, ma'am.
So 2, 2, 2. So here also, in case of C6, it will be 3, 3, 3. Okay? So how it is related with n? When n is equal to 3, it was 1. N is 3, it is 1. N is 4, it is 2. N is 5, it is again 2. N is 6, it is 3. N is 7, it is 3. So this is 5, again 2, 6 and 7, it is 3. How it is related? Eccentricity, diameter, radius, whatever you say. Everything is seen in the case of C any cycle. Tell me. Any formula that connects 3 with 1, 4 with 2, 5 with 2, 6 with 3, 7 with 3, 8 and 9 with 4, 10 and 11 with 5.
Floor value of n by 2.
Yeah, floor function of n by 2. Clear? This will be the eccentricity, radius and diameter in case of this one. Okay. Now what about a complete graph? Complete graph will be this one. Yes, complete graph. Yes.
And distance will be 1.
1, right? Every two vertices are adjacent, so you directly you can go to any other vertex and length is 1, right? So always eccentricity in Kn is 1, diameter is 1, radius is 1. Is that clear? Everybody?
Yes, ma'am.
What about Pn? Pn? This was in case of Cn. This was in case of Kn. What about Pn? Trivial graph, this is 0. Non-trivial, we have done it. 1, 1, right? 1 diameter, 1 radius. Okay, diameter and radius. What about P3? Eccentricity? Eccentricity of the end vertices? 2. Here also 2. What about this one? Eccentricity of this vertex?
1. 1.
1. So minimum is giving you radius 1 and maximum is giving you diameter 2. Okay. What about P4? This is eccentricity
3.
3 and what this is? And what about this one? 2. This is 1, 1, 2. Then here 1, 1, 2. Okay. So in case of Pn, if you will look at this one and so on up to, it is having n minus 1, the end vertices, right? Then n minus 2, n minus 2, n minus 3, these two vertices and so on. Clear? So here radius is 2, diameter is 3 and this is your P4. So diameter is just 1 less than n, right? You look at this line. For P2 it is 1, P3 it is 2, for P4 it is 3, for P5 it will be 4. The maximum is n minus 1. Na? So for Pn, diameter is what? N minus 1. What about radius? Radius. For radius it is, for P2 it is 1. For P3 it is again 1. 3. It is 1. 2 it is 1. 4 it is 2. 5 it is again 2. How it is related? Yeah. P2 के केस में 1 है, 3 के केस में भी 1 है, 4 and 5 के केस में 2 है, 6 and 7 के केस में it's kind of same thing, this one. Okay, यहाँ पे 2 and 1 के केस में 0 था, right? So 2 and 3 1 1, 4 and 5 2 2, 6 and 7 3 3, So radius of Pn is different from diameter, right? And that is radius is coming as n by 2 plot function and diameter is n minus 1. Is there any doubt to find eccentricity, diameter and radius? Diameter of Pn, radius of Pn. Or you can also say like this, ceiling function of n minus 1 by 2. Clear? That is also coming as same. Yeah, in case of complete graph it is 1. Okay, eccentricity is 1. What about case that is star part, k n minus 1, k2, k1 1, 1 1, k3 same as p3, you got 2 1 2. What about k1 3 or in general k1 n? These are n minus 1 vertices and this is 1. So what is the eccentricity of this middle vertex?
1.
1. You have one vertex, all the vertices are 1 in range, right? Yeah. What about this one?
2.
Every other vertex you can reach up to 2 length, right? 2 distance. Each vertex has maximum 2 distance. So diameter is again 2 and radius is 1. Except K11, it is same for all other, right? For n greater than equal to, that is order 3 होना चाहिए at least 1, right? At least 3. Then you have diameter is 2, radius is 1. For K11 it is 1. Clear? Any doubt? Yes. In this one, in this graph, eccentricity of this graph I already labeled. This is 4. Why it is 4? You have directly from here to here. No need to come to this one, right? You need smallest path length. This to this, this to this. Then no need to go via this, right? You can directly lead to this vertex or directly lead to this vertex, right? Or directly lead to this. And these are 4. 1, 2, 3, 4. These are the maximum possible, right? And to this vertex also you can 1, 2, 3, 4 or 3, 4, right? So you have maximum 4. This vertex, or this vertex, anything, right? This one or this one. Clear? 4, 4. These are the maximum possible. So diameter will be 4, right? What about the middle vertex? Middle vertex means except these vertex. For this one, this is one step inward, right? 1, 2, 3. You can reach up to 3 over here. And here 1, 2, 3. 3. And here 3, 3. So 3. For this one 3. For this one 3. For this vertex it is 2. You can directly reach up to this vertex or directly reach up to any of these within 2 range, right? So minimum it is what? 2. Clear? And that is your radius, and maximum is what? Maximum distance from any vertex. This is 4. Minimum distance is 2. That is your radius and diameter. Clear? Any doubt? Finding eccentricity, diameter, radius? Hmm? Now, if I give you tree, in graph G, whenever it has some cycle, you can find more than one path of the same length, right? What about tree? If I give you some tree, suppose this one. What is the eccentricity of diameter? Diameter. What is the diameter of this tree?
4.
4 or 3?
3.
Eccentricity of this one will be 3, right? And if we just do this one, then it will be 4, right? Now it's 4. Okay. For this one again, it is 2. For this one, 3. For this one, 3 again. 1, 2, 3. For this one, 4. Okay. Diameter is what? 4. Radius is what? 2. Clear? So in tree, the longest possible path you can just find it, and that will give you diameter. Why is it so? There exists unique path between any two vertices. Clear? Whenever it is a non-cyclic graph, connected graph, you can only find the longest possible path. So length of longest possible path will give you diameter of the tree. For example, in this one, longest possible path is this one, right? And this one we have done the same thing we have done. Yeah. Diameter is 4, and this is eccentricity for this and this. This one it is eccentricity will be for this one 3, for this one 3. For this one again 3. For this one it is 2. Radius will be 2. Clear? Why is it so? Because every path in a tree is the shortest path between its endpoint. Any two U2V point you can just take. And I told you that there will exist unique path. There exists unique. This is the notation for there exists unique path. Okay, between U and V. Clear? So you just find the longest possible path. Okay, that will give you the diameter. Clear? Any doubt? Yes? Understood?
Yes, ma'am.
Okay. Now for this one, if G is a simple graph, that means no vertices, no loops are there, then given its diameter of G is at least 3, then you can tell something about the diameter of its complement will be at the most 3. Okay? You just remember this. On the basis of that, you can solve some questions based on kind of this one only. Okay? So what is it? Diameter of G is at least 3 in case of simple graph. This gives you the diameter of its complement of this graph will be at the most 3. Clear? How to prove it? I'll just prove it. Don't worry. So on the basis of that, can we solve one question based on that? What is that? Yeah. Yeah, this one. Let G be a simple graph with diameter at least 4. Prove that diameter of G complement will be at least 2. And what we have theorem, diameter of G is at least 3, then we can say implies diameter of, that is this one, right? Diameter of any graph is at least 3, implies diameter of its complement is at most 3, right? Are you getting it? So we need to show if the diameter is greater than 4, greater than or equal to 4, then its complement will be having diameter less than 2. Suppose not. I'm just trying to prove by contradiction. I'll use this one. Suppose this is not less than equal to 2. So what it will be? It is greater than, right? Suppose this is not, it's any graph complement, you can just say. Its diameter is not less than equal to 2 means to say it will be strictly greater than 2. Okay. So if it is strictly greater than 2, so what is the possibility? It can be equal to 3 as well. Clear? So that means diameter of G is greater than equal to 3. Now diameter of this complement of this graph, take it as h. Then h its complement of complement. If you take this complement is h, then diameter of complement will be less than equal to 3. It is at least 3 now. Are you getting it? And obviously we know that simple graph complement will be again simple. Okay. The complement of complement is what? We have just applied that theorem that if diameter of any graph is at least 3, its complement will be at most 3. Okay, diameter of its complement will be at most 3. This means what? Diameter of complement, this is isomorphic to what? G, na? Clear? So diameter of G, you can just say, is at the most 3. Is it possible? If you are just saying, if this is not true, then that is negation Q you have taken, then you are just proving negation P. Clear? Given was diameter is at least 4, but we have proved this is not even 4, right? That is at most 3, which is not possible. That's why whatever we have assumed is wrong. So this thing, whatever we wanted to prove, this thing is true. Is there any doubt? Yes? No? We can just now. Tomorrow we'll be just solving these questions 2.1. Yeah, now we need to just show if G is simple, then it is given diameter of G is at least 3, then you have its complement is at most 3. So what is given? Diameter is 3. So diameter, what is the definition of diameter? It is the largest maximum distance between any two points, right? Over all the vertices. So there will be some 2 points U and V between which its distance will be same, right? Diameter is just maximum distance between some points. So those 2 points we have taken as U and V. Okay, we have marked in G. So if it is at least 3, means there exists non-adjacent vertices without common neighbor. Otherwise, अगर common neighbor हो सकता तो ये 2 ही रह जाता, right? Clear? Shortest path length find करते ना? Clear? अगर common neighbor होता तो ये 2 ही रह जाता, right? So 2 नहीं है, means to say what? There exist 2 non-adjacent vertices U and V without common neighbor, kind of this thing. Okay, at least ये वाला scene तो है यहाँ पे, right? There exists non-adjacent UV with no common neighbor. Okay, ये वाला scene नहीं है, means there is no common neighbor between U and V. Otherwise, diameter 2 हो सकता था, but it is given that at least 3. Okay, means to say neighborhood of U and V is 5. Clear? There is no common, that is neighborhood of U at intersection with neighborhood of V is 5 because there is no common neighbor. This is the possible scenario. Neighborhood of U में यहाँ वाले आएंगे, right? कुछ भी यहाँ. Clear? And V में it's like this one, these one, not from this one. These are having no common neighbor, right? No common element. This is your neighborhood of V. So let me erase this one. So the scenario I have already shown here. This is your neighborhood of U, where X point in general. This is your neighborhood of Y, here Y point. So there is no common from NU and NV. Okay. Here, neighborhood of U in G, that is this one. Neighborhood of V in G is this one. Now, what can you say? X, any X you find, Vx is not an edge in G, right? ये वाली edge नहीं है. Otherwise, X यहाँ पे भी present करता. Similarly, if you take any element from neighborhood of V, this edge is not present. Here, U to Y edge is not present and X to V edge is not present. Clear? V to X नहीं है, otherwise two length हो सकती थी, right? V Y नहीं है, right? Otherwise two length हो सकती थी. If they are not present in G, what can you say about G complement? In G complement, they will be present, right? So this edge will not be there. This edge will surely not be there, right? This edge will be there because X to V G में तो है नहीं, Y to U G में है नहीं, so G complement में रहेगा. Now, X to Y, if they are adjacent in G, then this will not be adjacent in G complement, and some members may be adjacent, may not be adjacent in G, they may be adjacent in G complement, right? So this edge is also gone. जहाँ भी ये adjacent थे G में, so G complement में ये वाला नहीं रहेगा, right? So what do you got? What do you got about diameter of G is at most? At most. See, you got distance in G complement from any two points X and Y. If they are not adjacent, then via V. Okay, X and Y are adjacent via V, via U, right? And U and V can be at most adjacent via these neighborhood. Okay, 1, 2, some edges will be there, and here. Are you getting it? What is the scenario in its complement will be like this. Some other points I have just marked. So in G complement, UV is, yeah, obviously this will be adjacent because in G that was not adjacent. Okay, that I forgot. Okay, so this UV will be adjacent in its complement. This one, UX will be, that is VX, there will be adjacency from here to here, here to here. UY, because they were not adjacent in G. Now you can just look at, this was the scenario in G. Okay, this was G, this is G complement. VY will be G complement. Okay, so UV, these, what is the distance between UV? 1, U to X, जो भी neighborhood में थे, G में U के, all those points have two distance from U, and similarly with is happening with V. Okay, all those points that were present in neighborhood of V in graph G, those are having distance 2 via X, right? From V, right? So any point C, for any point C that is present in neighborhood of V and D, this CD is not present in EG. अगर कोई ये CD as नहीं थी तो यहाँ पे present होगी its complement. So what can be the maximum distance? यहाँ पे 1, यहाँ पे 2, यहाँ पे 2. And what about X and Y? X and Y were adjacent in G, but these are adjacent now via V, U and Y. So what is the maximum possible distance? There is no other path connecting S and Y. So what can be the maximum possible distance? 3 na? X to V, V to U, U to Y. Clear? So distance from X to Y is 3. Now for each pair, either distance is 1, 2, 2 and 3. So what can be the maximum distance? 3 na? 3 will give you diameter. That can be at most 3, right? Is there any doubt? If you understood these two figures, then you can easily write down whatever it is happening. That is whatever the neighborhood, that will no more neighborhood in G complement. Okay, U and V were not adjacent, they will be adjacent in its complement, and X and Y were adjacent in G but not adjacent in its complement. Some C and D point not adjacent in this one, they will be adjacent in this one. Now you can just explore all the possibilities, and possibility will be at most 3 distance होने की है, not more than that. Okay, and that is giving you the diameter. So that's the end of this theory part. I'll start this one in next class. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.